Okay, this is a 16-week off-season training program by Charles Klein for HPE 555, and our focus is hockey. Hockey is an anaerobic sport which requires the average player to perform vigorously for 15 to 20 minutes of a 60 to 70 minute game. Typically, the player participates in 30 to 90 second periods on the ice with a 4 to 5 minute rest interval. These moments on the rink consist of intense sessions of high-speed skating, body contact, which requires the athlete to possess an adequately high level of anaerobic endurance and muscular strength. This sport unfortunately also puts the athlete at heightened risks for injury, and a proper, efficient, and effective strength and conditioning program can mitigate that risk. This 16-week off-season training program will outline the phases involved in improving and enhancing the performance of an 18-year-old male hockey player. Initially, we will discuss the physiological demands of hockey, then present a pre-performance or participation fitness physical assessment. The 16-week off-season training program is broken down into phases. The first phase will be the first mesocycle will focus on muscular endurance training. The second phase will emphasize muscular strength. The third will address cardiovascular output, and the fourth phase concentrates on agility speed training. Each mesocycle has a duration of 4 weeks. Each phase will be conducted and supervised by the team's strength and conditioning coach and the assistant coach. The needs analysis is two-part, addressing sport-specific demands and the physiological requirements for each hockey player. Hockey is a sport prone to collision, involves explosive multi-directional skating, and requires exceptional hand-eye coordination. Normal gameplay consists of 3 20-minute periods, and in the event of overtime, an additional 5-minute period is applied. Sport-specific movements include, but are not limited to, shooting and passing with a stick and a puck, stick handling, checking, skating, and explosive dynamic movement patterns. Physiologically, lower body strength provides acceleration in skating, agility, and solid checking. Upper body strength enhances checking ability and improves shooting the puck and puck control. Power is the most important in hockey. It enables the player to react explosively and contributes to speed, agility, shooting, and checking. The hockey athlete uses aerobic and anaerobic energy systems. During play, the heart rate may exceed 90% with an average of 85%. The VO2 max averages 5.81 milliliters per minute. Offensive players are active 35% of the game, whereas defenders on an average of 50%. Biomechanically, movement in hockey causes extreme shin angle stress during directional changes, anterior pelvic tilt, multiplanar movement, and large concentrations of adduction and abduction when skating. Since a hockey player's posture results in a consistent bending of the legs, the hamstring muscles are seldom fully stretched. When considering injury prevention, training should apply additional focus on flexibility and mobility exercises to counter underutilized muscles during play, and specific lower back and shoulder strengthening. This is Table 1, the example of our hockey fitness testing for the 8-year-old male athlete. The physical assessment of our player begins with a battery of muscular strength tests, starting with the vertical jump, then the bench press, 1 repetition maximum, squat, 1 repetition maximum, and a hand grip strength test. This is followed by an upper body muscular endurance test with the push-up. We then determine acceleration speed and speed endurance with a 40-yard sprint, followed by a 30-second wind gate test. The Wingate test is one in which the athlete's anaerobic leg power is tested through a 30-second period, pedaling as fast as possible on a cycle ergometer. The hexagon is an agility test. The hexagon is mapped on the floor using tape, each line a minimum of 24 inches. The subject starts in the middle of the hexagon and on command go jumps across the first line, then back across the same line to the middle, and continues across the next line, completing 3 full revolutions. The shuttlecross pickup, which is here pictured, is an off-ice hockey-specific hand and eye coordination and agility test where the subject runs a pre-mapped course replicating hockey-specific movements. Our final event is a shuttle run, or as we know it, the beep test, only it's performed on ice. This assessment is similar to running, and the subject skates for 45 meters to a pace signal for 1 minute. Then takes a 30-second pause and repeats the sequence until he can no longer keep up with the pace. Here's the Wingate 30-second test and an example of the hexagon agility test. Then we move on to Table 2, which is the muscular endurance phase, weeks 1, 2, 3, and 4. The 18-year-old is considered a novice when it comes to this sort of training. We're preparing him for college sports. Exercise performance will be closely monitored for correct form, and assistance will be provided when necessary. Emphasis is placed on the maximum number of repetitions possible, close to muscle failure. The push-ups, dips, and 40-yard sprints are intended to train to exhaustion. The goal is to expose the new athlete to lighter weights, enabling form perfection without risk of injury before beginning the strength developing phase. The initial focus is placed on the endurance of the chest, shoulders, triceps, and T-spine. The squats, leg presses, and lunges will ready the subject for more difficult and strenuous exercises involved in later phases. Phase 2, the muscular strengthening phase, weeks 5, 6, 7, and 8. Still a novice, the hockey player now enhances his strength. Exercise performance will continue to be closely monitored for correct form, and assistance will be provided when necessary. The repetition volume has been reduced and the weight increased. The exercises are more sport-specific, for example, forearm strengthening, and there is more utilization of dumbbell exercises and machines. An effective and correct deadlift is the focal point. Specific single joint lifts, for example, leg extensions, leg curls, and the machine bicep curl, will concentrate on strengthening those respective muscle groups. The 40-yard sprints can be adjusted in length, and the push-up serves to loosen any tightness achieved from this muscular strengthening mesocycle. Table 4. We move on to the cardiovascular phase, weeks 9, 10, 11, and 12. In this phase, plyometric exercises will be applied to increase the heart rate. The chest push with run, release, and box jump are sport-specific, enhancing some explosive movements required on the ice. The slide board, a hockey-specific agility exercise, will be applied as a timed event without repetitions. Ice sprints will incorporate skating as fast as possible for 50 yards, 10 repetitions. This will be followed by the participant exchanging his ice skates for inline skates and around the 400-meter track 6 laps. Stadium stair running and 100-meter sprints take place opposite the skating days, and again the workout closes with push-up. Here's an example of the slide board. This moves us into the final phase. Table 5, the speed and agility phase, weeks 13, 14, and 15. The final mesocycle focuses on agility, speed, and explosiveness. The young athlete is now leaving the novice status. However, exercises will continue to be closely supervised and monitored for correct and effective performance. Explosiveness is to be achieved through the power cleans and jerks, as well as a resisted run. The bounds, jumps, and throw will work on not only agility, but flexibility and range of motion as well. The 5-point agility run, hexagon drill, and 20-yard sprints are hockey-specific and emphasize not only agility and speed, but the exercises also raise the heart rate, enhance and maintain the cardiovascular output. And here we have an example of the resisted run. In summary, the 18-year-old male hockey player, although perhaps having participated in prior strength and conditioning programs while in high school or intramural athletics, not necessarily hockey-specific, is a novice to this comprehensive and demanding training regimen. The initial intense assessment and testing battery are required to establish whether our subject is physiologically and mentally capable of participating in this detailed 16-week strength and conditioning program. The game of ice hockey places demands on an athlete like few other team sports do. The austere environment alone, the cold, the hard ice surface, and the equipment that the player must wear in an indoor setting requires a special endurance, conditioning, and stamina. Certainly a football player wears considerably more equipment and plays in all types of weather. However, he is afforded the outdoor environment and plays on grass. And a basketball court surface is naturally not as hard as an ice rink is. Then there are the gameplay demands of skating with speed, control, and explosiveness, hand and eye coordination, and power when controlling the stick and the puck, and the ability to body check effectively. This 16-week strength and conditioning program has been designed to prepare the young beginner, as well as the veteran hockey player, to meet these sport-specific demands, excel, perform to their utmost ability, and prevent injury in the process. And eventually, should he pursue the hockey career, this could be his future.